Welcome back, everybody. Today we are going to look at a system. The customer says that he has water coming out of both the primary and secondary drains. So let's go see if we can get it all fixed up. All right, here we have the unit. I'm not sure if you can see it on this video, but it is definitely sweating all the way down, dripping down into the secondary and then out. Of course, this is pulling air in right here. Which is a big no-no. You're pulling that hot attic air in. I imagine that right there is going to fix it. But I'm also going to pull these covers off. Look at the insulation in there. See if maybe we need to insulate. But if you have air sucking into this drain pipe, you're going to have sweating issues, no doubt. The other thing I'm going to check is I'm going to get my temperature probe. I'm going to check the return air temperature here and the supply air coming out over here. I want to see the temperature split across this coil. Make sure it's not too high. Okay, so the cap's off this. This is on the return air side, but you can't just cap this because this is your pan overflow. So this is where your drain line goes outside and drains. If it clogs up and you cap this, it's just going to overflow inside the unit. So instead of just capping it, I'm going to build a P-trap right here and then fill that P-trap with water so the air can't suck through here. That way, if it overflows in the pan, it'll go through the P-trap and into the secondary, which has an overflow switch, and it also has its own drain. That way, if this drain line gets clogged up, the pan safety switch will shut everything down. As you can see here, I dropped the overflow drain line below the level of the pan. That way, if it overflows, if you go above that, it'll just overflow inside. You got to go down low, okay, lower than the pan. I dropped it down, and then I brought it back up, and you can see right there, I now have water from here to here, which prevents the air from going back into the unit and bypassing that drain line. Now I'm going to check the splits, and hopefully this sweating will be gone very quickly. Make sure you put your sensing bulb into the ductwork a little ways so you can already see it came down a little more. So let's just say 70 degrees. Supply air temp is 52.0, so not excessive. Puts us about 19 degrees. But I did find another issue while I was up here. This duct is actually leaking out in here, causing this sweat over here to happen. That's probably going to be a separate issue from the actual unit sweating, but yeah, need to fix that. Another job completed. I went ahead and taped around the panels of that air handler, just in case there was any attic unconditioned air getting into those panels. The sweating went away. I wiped down the underside of the unit. I also pulled the electrical panel off to look for rust on the motor, for the windings, the contactor, the heating coils, and I even pulled there was a control board for the blower. I went in and pulled that off and checked the backside to make sure there wasn't any damage due to water. The inside of the unit actually wasn't too wet. There wasn't a whole lot of moisture in there. It was just the outside of the unit. But it's better that the customer called and we got that handled. That was really an installer mistake. Whoever installed that unit should have known to put a P-trap on that, or to put an overflow switch on that secondary line on the air handler. Anyway, got that customer taken care of. Remember what I always say, if you don't take care of your customer, somebody else will. See ya.